Alright, we are going to work on page 25 from your EOC study guide. So get the worksheet that goes with it, get your name on it, the date on it, the period on it, and let's go. Alright, we're at the top of the worksheet, question number 1. I will read the question quickly and then we're going to go over it and underline things. You should do that when you're taking your test. Question number 1. The distance a car travels can be found using the formula d equals rt, where d is the distance, r is the rate of speed, t is time. How many miles does the car travel if it drives at a speed of 70 miles per hour for a half an hour? Okay, it's just straightforward. We're going down the road in a car. All right, let's look at this. All right, let's read it slowly. Pick up your pencil. We're going to underline things if we think they're important. The distance a car travels can be found using the formula d equals rt. That looks like that's pretty important. So notice I have a place. That's your formula. Let's write your formula down. Now it says where d is the distance. That's good to know. That's what that d stands for. R is the rate of your speed. Okay, that's R. And T is time. Okay. How many miles does the car travel? Notice we're not looking for the time. We're not looking at for the rate. We're looking at how far it goes. How many miles? That's distance. Okay. If it drives at a speed of 70 miles per hour, oh, that's a given. And that's my rate, isn't it? Write it down under the givens. Then it goes on to say it went for a half an hour. Hour is time, so let's write that down. Okay, got that? Circle it and write it down or underline it. Okay, now are you ready to plug things in? So we want to start out with d equals open parentheses. What are we going to put in the first set of parentheses? Well, that should be r, so that is 70. Second set of parentheses is going to hold your 1/2. Now, this is a simple linear equation, all right? But we got a fraction, so let's work on that. This is what I suggest. If you know how to do it another way and it works all the time, fine, because there are a couple ways to do this. But what I suggest, if you're still having problems with it, go open parentheses, 70, close your parentheses. Open your parentheses again. Go 1 divided by 2. Close parentheses. Okay, now hit enter. Okay, write down your answer. Circle the correct answer right below the box on your worksheet. Okay, we good? Now, I want to go back in and I want to look for the answers for the units. All right. Now, we've did this before for page 22, so we can do this again. All right, we know the formula. Write it down. All right, what are my givens? Now, I'm talking about units of measurement. So I noticed that my speed or my rate was 70 miles. Notice miles per hour. You say that all the time, right? So my rate is measured in miles per hour. All right? And my time is being measured in hours. Now, to plug this in so we can cancel it out, what are we going to do? Miles per hour. Remember, when you have the word per, you got a fraction. So what goes on top? The first word in front goes on top. Then you put your vinculum, and the last word goes on the bottom. And that's what you should have. Miles over hours. Now, I have hours, and I don't have a fraction. And when you don't have a fraction, you put a 1 underneath. Okay? What can you cancel out? Yes, your hours. And let's face it, shouldn't your answer be done in how many miles did you drive? Okay, does that make sense? All right. Now, I want you to do this again on the next page. Okay, we're at the bottom of the page. I will read this to you. You can read along, circle things. Notice I want you to get the your answer for your numerical and for your units. Okay, so let me read this to you, and then you can pause the video and get to work. Okay, the distance a car traveled can be found using the formula d equals rt, where d is the distance, r is the rate of speed, and t is the time. How many miles does the car travel if it is traveling at a speed of 63 miles per hour for 2/3 of an hour? Okay, think about how you did it in the last problem. Not that hard. You got the example at the top of the page. Pause your video and get to work. I'll see you on the other side. Alright, we should be on the back of the worksheet now, so turn it over. Question number 2 at the top. Again, slowly. I'll read it quickly and then we'll read it slowly. Question number 2. A certain population of bacteria has an average growth rate of 0.02 bacteria per hour. The formula for the growth of the bacteria's population is, oh, look at that formula, A equals PO, open parentheses, 2.71828, close parentheses. Exponent is going to be 0.02t. There's a exponent, there's a variable in our exponent. Okay, let's go. Where PO is the original population, T is the time in hours. Okay, if you begin with 200 bacteria, about how many bacteria will there be after 100 hours? Alright, let's go through it and underline, so pick up your pencil or your highlighter or whatever you got. Alright. A certain population of bacteria has an average growth rate of 0.02 bacteria per hour. May be important. The formula for the growth of the bacteria's population is, there's the formula. Let's just write this thing down. Alright, first thing we want to write down is A equal PO, open parentheses, 2.71828, close parentheses. My exponent is 0.02 times t. Okay? Got that written down. Now, wait a minute. Look at here, guys. 0.02. That's where that rate of growth is. They've already got it in the formula. I guess I'm not going to use it. Well, I am, but I don't have to write it in. Let's keep going. Whereas PO is the original population, and of course T is usually time, right? In hours, though, keep an eye on that kind of stuff. Your units. If you begin with 200 bacteria, that's my original population. My PO is going to be equal to 200. About how many bacteria will there be after 100 hours? Well, that's my T, isn't it? Let's write it down. Okay. Now, the only thing I'm going to have to plug into my formula is my PO and my T. So I like to write it down like this, using parentheses for where my variables used to be. So let's write it down. Okay. What are we going to plug in for the PO? Well, 200, right? And what do I plug in for my time? 100, because it was 100 hours, wasn't it? Now, we're going to have to do some calculator work. And this is new and a little difficult. That's not difficult, it's just new. So let's practice. If you can put this in your calculator and you know how to do it, fine. Otherwise, I'm going to walk you through using the school's Texas Instrument calculators, those blue ones that we have at the school. Alright, first thing I want you to do is open parentheses. This is calculator work. Do you see where I'm going to be doing this? I'm going to open parentheses, 200, close the parentheses. Now I'm going to open parentheses again and I'm going to put in 2.71828 close parentheses. It should be all in one line in your calculator. Now, on the right hand side of your calculator towards the top, you're going to find something that looks like that. This gets me into exponents. Now I can put anything I want up there. And this is what I want you to put in. I want you to open parentheses 0.02, do your time sign, put in 100, close that parentheses. Now hit enter. Okay, are we good? Go over and look at answers A, B, C, and D. Do you find your answer? Notice that they rounded. They didn't use anything past a decimal. So look at your answers, look at your calculator, and pick the correct one. Alright, your turn number 2. That's at the bottom of your paper on the back. I'm just going to read it through for you. You're going to need to underline. Remember how we did the calculator work on the previous one. Are you ready to go? A certain population of bacteria has an average growth rate of 0.02 bacteria per hour. The formula for the growth of the bacteria's population is A equals PO, open parentheses, 2.71828, close parentheses. Your exponent is going to be 0.02t, where P is the population, the original population, and T is the time in hours. If you begin with 400 bacteria, about how many bacteria will there be after 80 hours? Okay, I've got that all set up for you. Your answers are there on the right hand side. When you are done, turn it into teacher, show all your work. Okay guys? And great work working with you again. Bye bye.